Today we're going to learn about rational functions. Now the parent function is f of x equals 1 over x. And as you recall, that graph goes like this and like this. All right, it has a vertical asymptote here, a vertical asymptote at 0, and a horizontal one at 0. All right, the purpose of this lesson is to be able to graph a rational function quickly. If you can find the vertical and horizontal asymptotes first, it makes life easier. When you're looking for asymptotes, the vertical ones are what make the bottom 0, and the horizontal ones, or slants, or parabolic, depend on the degrees of the numerator and denominator. We always have to check for holes, okay? So here's, the first step is to factor, and then look for holes. Holes happen when you have a common factor in the numerator and denominator. Vertical asymptotes are what make the bottom 0, okay? What makes the bottom 0. The horizontal, it goes back to that little over big. You're talking about the degree of the numerator and the denominator. So if I have an x over an x squared, the bottom's bigger. It's got a higher degree. X squared over x to the 5th. The bottom's bigger. Your horizontal asymptote will always be at 0. If they're the same, you have x squared over x squared, and this is a 2 and this is a 3, it's your leading coefficient. It's going to be 2 over 3. If I have x cubed and an x cubed, and this is a 7 and a 6, it's 7 over 6. And what goes on over here doesn't matter, all right? Because we're really talking about end behavior. What happens when it gets huge? And the fact that this is cubed is going to overtake anything else that's happening in that problem, okay? If it's top heavy, you have x squared over x, you're going to have a slant, as long as the difference between here and here is 1. 2 minus 1 is 1. Or I have an x cubed over an x squared. 3 minus 2 is 1. You're going to have a slant. And you divide the bottom into the top, and it gives you the equation for the line. If it's bigger by 2, I have an x cubed over x. 3 minus 1 is 2. It's an x squared. That's a parabola. It's parabolic. And so your asymptote, instead of being a line, is going to be a parabola, and your graph is going to follow that. Okay? Now I made a complete mess out of this whole page, so let me erase some of that. And we'll go on and work some problems, and maybe it'll make sense. And remember, to find x and y intercepts, x-intercepts, you'll let y equals 0, and the y-intercept, x is equal to 0. All right? All right, so here's our first one. They want the domain. Well, the domain is whatever's left out of the denominator. So 2x plus 5 equals 0. So x equals negative 5 halves. So I'm going from negative infinity to negative 5 halves. And then negative 5 halves to infinity. The asymptotes, the vertical ones at x equals negative 5 halves. The horizontal, they have the same degree. They're both a 1, so it's at y equals 3 halves. X-intercepts, y is equal to 0. So you have 0 equals 3x minus 1 over 2x plus 5. You multiply by 2x plus 5. This goes away, and you get 0 equals 3x minus 1, so x is equal to 1/3. The y-intercept, you let x equal 0, and it's negative 1/5. There's no holes because there's no common factors. And let's talk about end behavior in a minute. So let's put in our asymptotes. This one's at negative 5 halves, so that's 2.5. And the horizontal's at 1.5. Okay, it's going through. X-intercepts is at 1/3, and the y-intercept is at negative 1/5. So this must have a curve over here. The question is, where's the other one? I'm going to plug in negative 4. You get negative 12 is negative 13 divided by negative 8 plus 5 is negative 3. That's a positive number, so it's up here. You'll notice I didn't find exact y values. I just sketched it. That's our whole goal. Now my end behavior, x is going to infinity. My graph is getting closer and closer to that horizontal asymptote. And x is going negative. It's also getting close to it. Okay, so it's going to approach 3/2. That's all there is to it. Okay, let's do another one. Factor the top first. Always the first thing you do. X, a 5 and a 3. This needs to be negative positive, and the bottom is x plus 4. There are no common denominators, so the bottom is, so there's no holes, so I can answer that question. None. The domain, you leave out negative 4. Asymptote is x equals 4. Now we're top heavy, so you're going to divide. I'm going to do synthetic division, negative 4 into 1, negative 2, negative 15. Bring down the 1, negative 4. This is negative 6. You add, that's 24. This is the remainder. It doesn't matter. Ignore, remainder. Because we're really worried about what happens when x gets huge, and you're going to have a huge number on the denominator, so this makes it 0. So here's my equation. Y equals x minus 6. X-intercept, y is 0, so it's just the top, so it's at 5 and negative 3. The y-intercept, you let x equals 0, so those go away and you get negative 15 over 4. Okay, now remember this is a slant, so let's put in our asymptotes at 4. And the slant goes through goes through negative 6. Okay. My intercepts, we'll switch back to blue, are at 5. Oh, that's the y-intercept, sorry. Are at 5. Dang it. And negative 3. Oh, that's weird. Really? All right, so it looks to me like we've got a graph that's going to be coming, and then at negative 15 over 4, which is what, negative 4 and something? This has got to be wrong. What did I do wrong? This is coming down this way. That should be positive. You sure that's not a positive 3? Huh. We need negative 15. No, that's right. I don't know. The graph's over here. Something's wrong with that picture. We'll have to figure it out. And behavior. X is going positive. Y is going positive. Okay? You can say it approaches the line, but it's really going to infinity. We're talking about the value of the y value. Okay? And it's going to be tracking that line. Yeah, we got to look at that. I'll come back. Rational functions. Okay, this one. It's top heavy. So you know, because this is one that's squared, all right, top heavy. So your asymptote here is y equals 0. Okay, unless there's a hole, we guess we better check for that first. We need a negative 6 and a positive 5, so that must be x plus 6 and x minus 1. Darn it. So now take that back. No asymptote. Because these cross out. So I have a hole at negative 6 to get the y value. You plug negative 6 into what's left, and you get 1 over negative 7. Okay, and behavior doesn't really matter here because we have a line. Yes, we do. Never mind. All right, so my domain has to go from negative infinity to negative 6 to 1, and 1 to infinity. Asymptote x equals negative 1, y equals 0. So x-intercepts, you let y equals 0, so there's none of those. It never crosses the x. That's interesting. And the y-intercept, you let x equals 0. is -1. Okay? So when I come over here, we got to do my asymptotes. There's one right here, and there's one right here, and it crosses here at -1. So this graph must be going like this. And then I've got -6, -1/7. There's a hole right there. So my graph is doing this. End behavior, x is going to infinity, y is going to infinity, x is going negative, y is going negative. Okay, out here, following that asymptote. Okay, 2 more. This one, I had to check and see if it was a factor, and I don't know how to factor a cube, so I at least did synthetic division. 1, 1, -8, and -15. 1, that gives me 3, so that's 4. That's 12, that's 4. So that's 12, and that's -3. So it's not a factor, so there's no holes. All right. The top's bigger than the bottom, so I have a parabolic, and I just did the division. So my parabolic asymptote is x squared plus 4x plus 4. My vertical is at x equals 3. My domain is -infinity to 3 and 3 to infinity. X-intercepts, you set the top equal to 0. I don't want to do it. And the y-intercept, you let x equal 0, so you got 5. End behavior, well, we'll have to talk about that. Let's see, if I graph this parabola, -b over 2a, -b over 2a is -4 over 2, so it's -2. It's my vertex. Is that right? Wow. I'm going to have a parabola in here. Okay. I'm going to have a horizontal, a vertical. That's in the wrong spot. Yeah, you just have to trust me. Y-intercept is at 5. Okay. So I'm going to have a graph that's coming down. It follows the parabola and then goes over here. This one's up here, I think. Way up there someplace. Okay. If I plug in 4, you get 4 cubed plus 4 squared minus 8 times 4 minus 15. Yeah, I think it's up there. And behavior. Now, it's following this parabola. Okay? This is going here. This parabola is going here. All right? So as x is going to infinity, y is going to infinity. And as x is going to -infinity, y is still going to positive infinity. Okay, x is going this way. My graph is going up following that parabola. That's a fun problem. I like it. All right, last one. I don't like factoring cubics, so I did long division. Okay, I got x squared plus x minus 6 into 2x cubed plus x squared minus 13x plus 6. Multiply by 2x, you get 2x cubed plus 2x squared minus 12x. Remember, you're subtracting, so I get -x squared minus x plus 6. So I multiply by -1, and you get -x squared minus x plus 6, and sure enough, it's a 0. Okay? So I have a common factor. So the top is x squared plus x minus 6 times 2x minus 1. And the bottom is x squared plus x minus 6. And I said, oh, wait, that factors. So this is x plus 3, x minus 2, 2x minus 1, and x plus 3, x minus 2. Okay, I have 2 holes. I have one at -3, and I have one at 2. In order to get the y value, you have to plug it into what's left. So I have a line with 2 holes in it. Negative 3 is negative 6 is negative 7. And 2 is 4 minus 1 is 3. So at 2, 3, there's a hole. At negative 3, negative 7, there's a hole. And I got a line going like this. Isn't that cool? How fun is that? So your domain, negative infinity to negative 3, negative 3 to 2. I got to get rid of my work, sorry. And 2 to infinity. Asymptotes are none. X-intercept, dang it. My y-intercept is here, is at negative 1. The x-intercept is at, what? A positive 1/2. End behavior, x is going to infinity, y goes to infinity, x goes negative, y goes negative. That's just so cool. Love it. Anyway, that's all there is for the lesson. I know that was fast. Hopefully a lot of it's a review. You can always pause back up and listen to it again. Thanks for listening.